there are approximately 2 billion daily active users which are there on Facebook as a platform, and on monthly basis this is around 3 billion users. Hi, welcome to Design Strong. So in this video today, we will design Facebook as part of our system design interview series. And in case if you're new to this channel, do not forget to hit the subscribe button. I think most of you will already be aware about the kind of functionalities that Facebook supports. For the sake of this interview, let's see what are the functional requirements that we are going to support. So our Facebook system design will support user sending out update in terms of status, and these status can be text status, images or videos. Then the next functionality that we'll see is user will have a timeline which they can visit. So this timeline will contain all the content that has been posted by users whom they are friend with. Friendship in the Facebook model works in two-way mechanism. So let's say if A user is friend with B, that means B also is in turn friend with A. What does that mean? Is A on their timeline will see what updates has been posted by B, and similarly B will also see updates which has been posted by A. Next, there will be minor functionalities such as user profile and who can visit whose user profile, and consider user profile as a timeline which contains details only for one specific user. And apart from this, we'll also create one section which is specifically for auditing purpose, wherein user can see all the activity logs for all the activities that a user has performed. This can include posting updates, watching a video, or liking, sharing, or let's say commenting on anybody else's content. Now let's see what are the non-functional requirements. So for any social media, the first and foremost requirement is that we need to understand that social medias are a read-heavy system. What does that mean is, let's say if I am friend with 100 users and I'm posting a content, this write is only happening once when I'm posting this content, whereas if 20 users out of those 100 friends are, let's say, visiting the timeline, they'll be able to see the content that I have posted, which would mean that read on the same content will be more when compared to writes. Next non-functional requirement is that we need to understand that the content loading on timeline should be fast enough. What does that mean is, let's say if a user is visiting timeline, we need some mechanism to be able to, let's say, auto calculate it, or we should have the timeline ready with us that we can show to the user instead of calculating or getting all the updates during runtime. Another non-functional requirement will be lag to an extent is fine. What does lag mean here is, in case if I am posting a content and if this content is not visible to my friends for next 20 seconds, this is fine. But in case if this content starts loading for my friend, this should be fast enough. So this is lag, which in terms of social media platform like Facebook or even Twitter for that matter, which we designed earlier, is fine. Next, let's talk about scales. So in terms of scales, there are approximately 2 billion daily active users which are there on Facebook as a platform, and on monthly basis this is around 3 billion users. So this is just a scale which we are considering to see what sort of a system that we are going to design. These numbers are very vague. In terms of images, let's assume that there will be 150,000 images per minute which will be served by Facebook. Let's also consider that there will be 300,000 status updates which will be there, and approximately 500,000 comments on others content which will be there on Facebook as a platform. So these are non-functional requirements that we are going to consider while doing this design. Like we did it for Twitter, we'll also divide users in 5 categories here. One is active user, inactive user, famous user, live user, and passive user. Famous users are users who are going to have like a big following. Active users are the one who have, let's say, logged into Facebook in last 3 days and which are active. Inactive is nothing but like a soft delete. Passive users are ones who uses the platform but on very rare occasions. So these user segregations will ensure how we utilize the concept of cache in our system design. And in case if you're new to this channel, do not forget to hit the subscribe button. Now in high level design for Facebook, first we will see the user sign up flow, then we will see friend request flow. There will be other flows which we'll be covering, but for now let's focus on these two. So user sign up In case of user sign up, the request will come to load balancer. Consider this load balancer as incoming proxy, authentication and authorization layer, and a load balancer in itself, which will be responsible for balancing the load across internal services. Now, as and when a user signs up on, let's say, the app or mobile, then the request via load balancer will reach to the user service. Now, user service will be connected to a database which will be an RDBMS. Something like AWS Aurora will work because they'll have unlimited IOPS which will be there. Amazon Aurora is going to work absolutely fine here. Why we have chosen RDBMS here is because the data is going to be very relational. The data for two users are not going to differ in terms of the type of data or the layout of data. So let's say every user will have a first name, a last name and things like that. Plus I expect there will be only, let's say, one row per user, and if we consider all the users which are going to sign up, I think sharding with MySQL on Aurora will work absolutely fine. Similarly, that means there will be one user which will be connected to multiple users. There will be a user connection service which will be responsible for handling all the connections, and this also will be utilizing an Aurora MySQL database for handling the connections across multiple users. So a connection across multiple users will be stored in the format of a matrix. So let's say if user A is connected to user B and C, that means there will be two rows into the table which is storing this connection, wherein user 1 and user 2 are the columns name, and user 1 will have A and B, and next row will have A and C. So this is how the relation will be defined. And reverse relations while being stored will also need to consider that if, let's say, user A is connected to C, we need not store a connection between C and A again. Both these services will be connected to a cache in form of Redis. Why we are storing data in Redis? Because we want to serve these two in very less time. So we can utilize concepts such as 80-20. That means 20% of the users who are generating 80% of the traffic, then we can store details for these users in terms of their connections and their user info in Redis. Now these services, user service and user connection service, will also be connected to a Kafka queue, and this Kafka queue will act as input for other services in the system, which we will see next. Next, in the Facebook design question, we will see how do we handle the scenario where user posts some content, user visit timeline, and user checks their or somebody else's user profile. So first consider posting a content. Let's say a user is posting content, and this content can have status, image or video. So this post content will request the load balancer, and via load balancer this request will come to post ingress service. So consider post ingress service as the first service which will be responsible or will be the source of truth for any status update or posting of content which is happening. Now this post ingress service will be attached to a URL shortener. So what does a URL shortener do? This is a system as a whole in itself which will be responsible for, let's say, shortening the URLs which are there and creating some analytics around it. We have done a video on URL shortener. I will provide the link in the description so one can visit that as well. Now post ingress service will be connected to content service. So content service is going to be responsible for storing and retrieving of images and videos. So content service will be connected to something like an Amazon S3 over a content delivery network, so that this data can be retrieved in a short span. So content service you can consider as a system as a whole, like YouTube or Instagram or Netflix, which is responsible for hosting the content and playback of it as well. This post ingress service will also be connected to a Cassandra DB, which we are calling here as post Cassandra. Why we are choosing Cassandra here? Because we have seen the scales of 300,000 requests per second which will be coming in. So Cassandra will work perfectly fine. One thing to consider for this post Cassandra database is we need to ensure that how the partition has been done. So for example, if partition has been done on the basis of created at date, then there can be a situation that only few partitions are working and rest are just lying out there. So we need to ensure that we are using a good partition mechanism. Let's say something like base 9 or base 10 of user profile ID works really well. Or what we can do is we can have a custom partition as well which stores users in such a way that not all the users of a specific type lies in the same partition, because let's say if all the famous users lies in same partition, then so that partition will have more load than others, so we need to avoid that as well. Now this post service will again be connected to a purge service. So purge service will be responsible for cleanup of data which is available in post Cassandra database, and this is to ensure that Cassandra does not get overwhelmed with data. So we can have a secondary database, again a Cassandra, wherein old data can be posted out from the live database. So purge service will be responsible for any sort of purging which will happen in databases and caches. Now this post ingress service is also connected to a Kafka queue, wherein they will be providing an update as and when post has been posted by a user to a Kafka topic. This Kafka topic will only contain detail of the status message in terms of, let's say, a status ID which will be available in post Cassandra database and the user which have posted this. Now this Kafka queue is going to be responsible for providing all these details back to other services in the system. So let's say whenever there is a Kafka event, we can also have an analytics service which will be responsible for the last functional requirement that we discussed, which was for having audit sort of purpose, wherein we can see what are all the operations that user has done. So Kafka can be queried for that as well. Plus notifications from Kafka service will be consumed by post processing service as well. Now post processing service will be responsible for updating the timelines. So for instance, let's say A user is friend with B and user A has posted this content. Notification goes to Kafka, and then post processing service will question user service to ask who are all the friends of this user so that I can update their timelines. So post processing service will does this operation and post an update into the Redis. Now Redis, again like Twitter design that we have seen earlier, will be responsible for storing timelines which are pre-calculated. So for example, if this is an active user, we don't want them to wait for, let's say, 10 seconds to load their timeline, because that will be not a good user experience. So we want to pre-calculate their timelines as and when they log in. We just query the Redis and provide back the timelines. For getting timeline and user profile, these two operations will be dependent on content delivery network. So this content delivery network is again part of this content service. I have created it here so that it is easy to understand in terms of diagram, and these operations will be handled by timeline service. Timeline service will be connected to user service, and it will also be connected to Redis so that timeline can be served. And this timeline service will also be connected to post service, which is connected to post Cassandra. So for instance, if this is an inactive user, he comes, Redis will not have the details. Timeline service will ask post service, send me the data for this service. Post service will then calculate this on the basis of post Cassandra and send it back to timeline service, and this will be shown into the timeline for the user. Similarly, Kafka operations will also be consumed for deciding whether this user is online or not, and this online user service will be responsible for sending out notifications to the user app so that they need not update their timeline in case if there is new content, and that can be worked upon a push mechanism rather than pull. So this sort of design is good enough for a discussion of around 40 minutes to 1 hour with a system design interview or an HLD interview, wherein the interviewer is asking for a Facebook system design. There are other components as well for this system, which can be like comments, liking status, etc. But just for the sake of simplicity, we have only covered these aspects. Other aspects can work similar to what we have seen in Twitter designing as well. Plus, there will be other videos which we'll be doing in near future, which will cover this content service. So I am planning to do a video on YouTube design and let's say Netflix design, and those will cover these two. So I hope this is a very small video which will be able to help you prepare for a Facebook design HLD interview in terms of system design interview.